In this question, you are required to find the Maclaurin series for this function and its radius of convergence. So this function can be written as f of x is equal to bring um, 2 minus x up with a fractional power. So what we'll end up with is 2 minus x to power negative a half. And then what I'm going to do is to factorize out 2. So basically I'll have something like this, 2 in bracket 1 minus x over 2, okay, to power negative a half. Remember, if I expand this bracket, I'll still end up with what I have on the left, and everything is still to power negative a half. So I haven't changed anything. Now this will be equal to 2 to power negative a half multiplied by 1 minus x over 2 to power negative a half, which can be written as 1 over square root of 2 into 1 minus x over 2 to power negative a half. Now, the reason why I'm rewriting it this way so that I can be able to use my previous Taylor series, Maclaurin series expansion for 1 plus x to power k to be able to expand this as well. Now, anyway, so I know that from my previous video, 1 plus x to power k is equal to the sum from n is equals to 0 to infinity to k into k minus 1, k minus 2, up to where I stop, which is given by that. We derived this previously over n factorial, and all this is multiplied by x to power n. All right, so this is the series representing this function. Now, what we want to represent is this. We want to represent 1 over square root of 2 into 1 minus x over 2 to power negative a half. All right. Okay. This is what we want to represent this guy here. All right. We want to represent this guy here. So what you're going to do is look for some connections here. Now, in place of x, I'm going to replace that. In place of k, I'm going to replace that. Okay. So basically, what I'll end up with is the sum. I may need some more space here. From n is equals to 0 to infinity. And then what I have is if I replace a half, that will be negative a half. So that will be negative a half into negative a half minus 1, negative a half minus 2, up to negative a half minus n plus 1, and then multiplied by negative x over 2. So instead of writing, can just write negative x over 2. That's what you're replacing with x to power n. All this over n factorial. And then I have to simplify this. So this will be equal to the sum from n is equals to 0 to infinity. And then what I have is negative a half multiplied by negative 3 over 2 multiplied by negative 5 over 2 all the way up to a half. So negative a half plus 1, that will be a half minus n. And then whatever I had next, that negative x over 2 to power n. All this over n factorial. What that will give me is the sum. I can leave it like that. I don't even have to go further than that. So basically, that is a series representing that function. And you can expand it to whatever term that you've been asked to. Now, to find the interval of convergence, replace x with the negative x over 2 in the original interval of convergence of 1 plus x to the power k. So to find the interval of convergence plus x with negative x over 2 in the original interval of convergence of 1 plus x to the power k. So, which means now we know that the original interval of convergence of this guy was all values of x that are between -1 and 1. Now, what you're going to do is to replace this with so you're going to replace this with negative x over 2. All right. So to get the interval of convergence of the new guy. Anyway, so if we replace that, what we'll end up with is we'll end up with the absolute value of negative x over 2 is less than 1, which is the same as this is the same as absolute value of x over 2 is less than 1, or we can say x absolute value of x is less than 2. All right. So basically, the radius of convergence is 2. All right. So the radius of convergence, this is actually the radius of convergence. So that is the radius of convergence.